Example 3, this one's a little bit trickier and not as much has been given to us, so let's take a look. Y equals x squared. We're gonna draw the two-dimensional shape here. Y equals x squared. We know that goes through 1, 1, and 2, 4. Y equals x squared. Well, about the line x equals 4. Really? I don't know if I like that. Now let's do this. Let's call this 2, and let's call it 4. Okay. So y equals x squared, 2, 4, 4, 8, 12, 16. So we can adjust it here so it'll fit. And then we have y equals 0. Okay, well that's that. X equals 4, and that's that. Okay. Now we're going to rotate this region around the line x equals 4. So we're not rotating it around a horizontal line anymore. We're going to rotate it around a vertical line. Okay. We're going to apply the same principles. We drew the curve, and then we're going to draw a rectangle. But if we're rotating it around the vertical line, our rectangle is going to be horizontal. Okay, the rectangles before were all vertical. I'll zoom in a little bit here, make it a little bit better. Okay, let's see if we get a better focus there. Okay, so here's our rectangle, and then we reflect that curve, our y equals x squared, about the line x equals 4. So the x equals 4 is our line of symmetry. And so this point here will be over here. We come down like that. Not great, but I hope you get the picture. And then we're going to take that. Oh, I'm drawing my rectangles in red. Sorry. I have a hard time getting my pens out. So we're going to take our rectangle and we're going to rotate it. Let's see, around like this. Okay, and then back around the back side. Not as happy with this one as I have been. When the rectangles get smaller, it makes it a little bit harder for me. Well, anyway, hopefully you can visualize that rectangle being rotated around that vertical line and all the way back, making kind of like a hat shape, as you can see. Okay, and then we need to find the volume. Okay, and to find the volume, we need to look at that disk. Okay, so let's take a look at one disk, and now the disk is already in the position we want it in. Okay. Now what's the radius though? Okay, there's the true test. Have you been paying attention? Well, the radius is a horizontal line. Okay, it's a horizontal line segment in terms of y. Okay, well, what did that mean in terms of y? I don't know. Let me think back on that one. So the rightmost curve minus the leftmost curve. And guys, we're going to be integrating or adding up an infinite number of volumes of disks from the bottom to the top. Now here we're going to go from 0, which is the bottom boundary, all the way up here to 16. Okay, so our volume, let's see if I can squeeze that in. The volume is going to be the integral from 0 to 16. Because we're adding up a bunch of volumes of disks. So the radius is that distance between that curve right there, which is x equals 4. So 4 minus. So don't forget, just like in the area between two curves section 7.2, you had to express the distance between 2 points horizontally, and that's always the right minus the left, the bigger number minus the smaller number. Well, don't forget that this curve right here is not in terms of y yet. This curve was given to us as y is a function of x, so y equals x squared. So if we take y equals x squared, and we have to solve for x. We can't just put an x squared there. We have to solve for x. Remember, when we're integrating with respect to y, the functions need to be in terms of y. And so we're going to go ahead and take the square root of both sides. And so we did this plenty in section 7.2, so this should be pretty easy for you. So we get the square root of y plus or minus the square root of y is equal to x. Well, if you were to plot a couple points, we have the points 0, 0. That's not going to help us. We have 2, 4, and we have 4, 16. Well, the only way, if we plug in 16 for y, that we're going to get 4 for x, is if x happens to be the positive square root of y. So this curve right here can be called y equals x squared, or we can call it x equals the square root of y. Of all the things that will trip you up in problems like these, that's going to be it. Expressing x as a function of y. And that's how you do it. Okay? So please make sure you put time and thought into that so you understand, because again, that's where the students will make mistakes. So given that, we know now that our radius goes from the right-hand side, which is 4, x equals 4, to the left-hand side of that line segment. And the left-hand side of that line segment is bordered by the curve x equals radical y. So we have 4 minus radical y as the radius. So it took a long time to explain that, but once you get that, then you're looking pretty good. Because we know that the volume of one disk, I'm going to write that down, volume of one disk. And I'm going to just mess with you a little bit there and just put a K on the end of that instead of a C. So the volume of one disk is going to be pi times the radius squared. Okay. Pi r squared times the dx. Oops, sorry, the dy. And we get 0 to 16 pi times, what's the radius? That's 4 minus the square root of y squared. That's another one that I always forget that unless I'm really concentrating. It's easy to do it. Pi r squared. Okay, so make sure you put that squared on there, and then you get your dy. I'm going to go ahead and type that into the calculator, and I encourage you to do this because if yesterday was any indication of where we're weak here, it's using the calculator. So I want you guys to be using your calculator a lot. Okay, so I'm going to type that in, take a snapshot of that, maybe pause the video right now while I go ahead and type it in. And let's see, can you see that okay? That's pretty bad. So we're going to type in our y1 as our pi, don't forget the pi, times 4 minus the square root of x. Don't forget that y in there is a dummy variable. So pi, that's the radius, 4 minus radical y, and then here x squared. Okay, so there's our integrand. Once I have our integrand in there, then I can just math 9 it. Math 9 integral of y1, comma x, comma 0, comma 16. And there you go. You should be able to get the number that's going to show up here any moment now. Any moment now. Just go ahead and show up. There we go. 134.041. Okay, 134.041. There you go. 134.041. And there you go. So hopefully that was doable for you. Okay, I'll see you in the next video.